presentation on resolving furnace and AC RFI problems with supplementary information about resolving EMI RFI problems in general. And I'll start out by mentioning the excellent ARL RFI book, 3rd edition, edited by Mike Gruber. I'll also mention it does not have a chapter on furnace and AC issues, which is kind of interesting. So perhaps this presentation could be viewed as a supplement. The terms EMI and RFI are used interchangeably here by me, but EMI is any charge from a static belt, for example, could be considered to be EMI. But when I talk about EMI or RFI, in either case, we're talking about the same thing. Now, the basic principle for finding local RFI sources is by elimination, because sometimes it is good to be out of the loop. A few quick terms that I'll use over and over again. I've tried to make the fonts in my view graphs large, so they're readable. AC without a slash stands for alternating current. A/C stands for air conditioning unit. This probably isn't standard, but we're going to run with it. A common mode noise, which I'm going to elaborate on, is a noise that's in phase in 2 or more conductors of an antenna lead or other differential signal source. There has to be a ground return path to get common mode noise. The next slide illustrates that. These are 2 figures borrowed from the ARL RFI book. In the left-hand figure, if you follow the arrows, it's actually the transmitter, which is the source of our problems. This suggests that the transmitter is causing some RFI to be propagated along the AC lines through an AC line into a house, and at the same time the antenna itself is radiating what's called radiated RFI. In other words, basically a broadcast, which might be picked up by the TV antenna now, or maybe that's supposed to be a Yagi. Let's assume so if the book is current. But conducted RFI is conducted on the AC power line. Radiated RFI is transmitted through the air, and that's a fundamental distinction. The right-hand illustration just illustrates a common mode signal with a ground return, as with a long wire antenna. In the upper figure, there is no ground, and you have a proper differential signal on the 2 leads for your antenna. In the bottom figure on the right, you have the same signal present in both differential leads with a ground return. And the issue of common mode noise is going to come up repeatedly. So here's the generic common advice, and actually it did work for me. You begin by turning off everything electrical in your house if you're having a problem. Fluorescent lights, computers, cell phone chargers, television, monitor box, routers, furnace, air conditioning. This may not make you popular in the dead of winter, but it works. You turn things on individually. And with the furnace, I will talk a little bit more about the issues involved. You finally, if you can document the RFI with screenshots, which I'll show you in a subsequent slide, that can be very, very useful for getting help. It documents the problem, shows the frequencies, and can help you communicate by email with other people. So it's possible in some cases to determine immediately whether you're dealing with conducted or radiated RFI. If you have a rig that can be operated on battery power, and you go to battery power and you still get interference, then you're dealing with radiated RFI. You may also have conducted RFI in the power line. They are not mutually exclusive, but you can be pretty sure you've got a problem with radiated RFI if you're running on batteries and you still have strong interference. There are sniffers available. They're called RFI Sniffers. The modest price one that seems to have received mixed reviews is MFJ's 856. As a proposal, the club might want to actually buy one. Gigaparts has it for about 140. It has a small 3-element directional antenna. Its tune, the sweet spot, is 130 megahertz, which I find puzzling given what we're interested in. And if you look on EHAM, you'll see mixed reviews. Generally, the reviews are good with respect to utility and cost, and The questions raised concern quality control with MFJ, which is almost a universal concern. RadarEngineers.com makes commercial units. They didn't post their prices, and I knew better than to ask. Somebody said, well, I'd buy one, but it would probably cost more than my entire station. In the ARL RFI book, there's even plans to make a very simple sniffer, provided you can provide either a radio or a television at the appropriate frequencies. You can make a very simple antenna designed to detect RFI leakage around the chassis. That antenna will mainly detect the magnetic field, which supposedly is going to be strong in near field when you do have leakage, when you do have RFI leakage. So now let's talk about what actually happened. I'll summarize quickly what my rig is like. I have a 65-foot end-fed antenna. Comes down through the deck, the coaxes do, goes in through a window about 12 feet from an external air conditioner. I also have a common mode choke between the downfeed and the lightning arrestor, because end-fed antennas often have problems with common mode noise, and I bought it preemptively rather than after the fact as a remedy. But I've tried operating with it and without it, and it does seem to lower the noise floor considerably. And then finally, the IC7300. I'd hate to be the only ham that doesn't own one. Has a built-in monitor, and if you're getting interference, you can take screenshots. So I think the moment of reckoning was when I was trying to work the world's most boring net on Thursday, Mike's net, at, let's see, it's at 28.444, and at 28.448 there was this enormous band of noise, and I could barely work the net. And I said at that point, I'm tired of trying to work around this. But the problem had been going on for about a year, and it was intermittent. Sometimes it was there, sometimes it wasn't, which can be one of the maddening things in any sort of RFI problem. But the next day it was still there, and I figured out it was still there because it was a cold day and the furnace was on. And when I turn the furnace on, I get very nice picket fence RFI interference. I now know it's from the furnace blower motor, but more about that in a bit. So on the right, the furnace is on, main blower's on, and the bands are approximately 18 hertz apart, perfect picket fence, just a real joy when you're trying to work on any band. It's somewhat worse on 10 meters, but I could see it on 20 and 40. I mean, this was a universal problem. Well, at that point I dug out my contract. It's a relatively new system. It was installed by a local company, which was very helpful, so I'll mention them by name. That's Ace Heating and Cooling, ACE. It's a Fairfax HVAC company. And I have a 10-year warranty. They had appended a 2-year warranty on top of it, which had expired. But I called up and explained what the problem was, and they sent a service technician to come out. And we did the before and after. Turn on the furnace, I'm getting all this noise, turn it off, noise goes away. That was actually a really important thing to discover. Then something even more interesting happened. The AC technician said, have you tried running your radio with the air conditioning on? And I said, no, should I? And he suggested that I do, and we turned on the AC. Now, of course, you can't have the air conditioning on without having the blower fan in the furnace on to circulate the air. And when the AC went on, sorry, where's that? When the AC went on, I got these extremely strong bands. They're about 35 kilohertz apart. And behind them, you can still see the picket fence interference from the blower motor in the furnace. So now I had 2 problems. It turns out I might have had 4 problems, which I'll explain. What to do? Well, Ace said, could you do me a favor, since you've got all this equipment, could you document this and write a memo? And I will forward it to Lennox, because Lennox actually manufactures the furnace. So I did so. Now we're waiting for Lennox field service to come out, and they came out twice. I want to do a quick segue. First of all, I want to talk a little bit about furnaces and AC components. A modern furnace has 2 fans. One is called the Induction Fan, which draws air from the outside. In this version, I said it's rarely a source of RFI. But just today, a Lennox engineer looked at this and he said, you know, more and more of our induction motors are actually high efficiency motors and are as likely to be a source of RFI as any of the other motors. So I really should change that particular bullet. Then second, there's the blower fan, which circulates heated and cooled air. The air conditioning unit, which in my case of course is outside, has a compressor motor and a condenser fan motor. So here's a quick picture. I won't dwell on it, but it shows schematically what's going on. In a furnace, both the blower motor and the induction motor can be what are called ECM motors. Whoops, something I'm going to explain. And the AC has two motors, a compressor motor, which compresses the fluid, and a condenser motor at the top, usually, which drives a large propeller, which condenses the fluid as it goes through a network of tubes. And both of these can be potential sources of RFI. And I just talked to a Lennox engineer today. He says, so in a modern unit, you can have 4 independent motors, all of which can be sources of RFI. Isn't life fun? This is my furnace, literally out of my manual. The combustion air inducer is on the left, which turned out not to be the problem. The blower motor is down lower right, about an inch from the wall, which had some consequences. And I probably don't need to dwell on this again. This again is just showing how an AC unit works with a compressor on top, a condenser on the right. The important point from our standpoint is we have 2 motors. One is a condenser motor, which drives propeller on top of the unit. The other is the compressor motor, and that's going to be present in any air conditioning unit. So why am I bothering you with this? Well, here's why. Everybody likes to have highly efficient air conditioning units. But the reason they're highly efficient is because up to 4 of these motors can be what are called ECMs, electronically commutated motor. If you look on the web, you'll find that acronym ECM expanded different ways, but the expert I talked to said this is the proper term. And an ECM can be used for the furnace blower, the compressor, or the condenser fan, or I should add here, also for the induction motor. So what is an ECM? Well, it's actually consists of 2 parts. One is a permanent magnet rotor inside of an armature, and that's the commuterless motor. It should say electronically commuterless motor. And then there's the motor control. And the motor control is where the problems are, because the question is, how do you drive these motors at variable speed, which is what makes them efficient? If you don't need a lot of cooling or a lot of air circulating, the motor slows down. If you need high compression or high air circulation, the motor can speed up. The specs I looked at suggested the range of speed is from about 600 to 1200 RPM. And this particular motor is made by Regal Belvoir. It has 2 connectors on it, which will have some import, and I'll explain why. The 5-pin connected to the motor, which is the motor in my furnace, always carries 120 volts AC. It's only a 0.5 horsepower motor. It's always on. The 4 or 16-pin connector to the motor carries the low voltage control signals. And the motor itself, I think, operates on 24 volts DC, but I'm not positive. And here is the gist of why this is problematic. The easiest way to have a commutatorless motor vary in speed is to generate a sequence of pulses of varying width. What's not shown here, but what we all know, is this is followed by a rectification and smoothing network. So if you have narrow pulses far apart, you have a low average voltage. Wide pulses, you have a high average voltage. After you smooth that out, you get a nice DC voltage, which drives the motors between 600 and 1200 RPM as a function of your heating and cooling requirements. Now, that part's wonderful because it's very energy efficient. The part which isn't wonderful is in your furnace and your air conditioner. You have a high-speed switching power supply, and you have a signal generator, and it's operating at very high frequencies, and this can be problematic. And in my case, it certainly was. So, why do switching power supplies cause noises at all? Well, first of all, as I just mentioned, you have frequency harmonics because you have a pulse generator inside the control circuitry for the motor. Then you can get underdamped oscillation in the switching circuit, according to Samlex. And then finally, those pulses go through a rectification network. And if you pass linear pulses through a rectification network, you're going to get some interesting harmonics because it's a nonlinear input waveform. And Samlex, if you go to their website, they're quite upfront about the fact that switching power supplies can be a source of RFI noise. They're also very efficient. Now to get back to radiated RFI. I mentioned previously RFI can be both conducted and radiated. The expert I talked to said that if there was actually a short line cord to the furnace blower motor rather than a long wiring harness, the radiated RFI would probably be very low. The gentleman I'm referring to is an RFI specialist with Rigaud Bellois, located in Fort Wayne, Indiana. He's been very helpful. Lennox put me in touch with him. He said actually when they get a new blower motor, he takes it home, puts it in his garage, puts a very short cord on it, and verifies using his own ham radio equipment that there's not much interference. So why do we get interference? Well, the answer is you get unintentional antennas created by the wiring, which permit what is actually a legal level of conducted RFI to be radiated from the ECM motors. In other words, these long wiring harnesses act like antennas, and they are carrying, and they permit conducted RFI from the control unit in the motor to go back onto the AC line. Furthermore, and this is just an observation on my part, which someone like Ron could comment on, I'm sure, you can actually have a resonant circuit set up this way by accident. I don't know how many people here are familiar with quarter wavelength resonators. Yep, a lot of people. They're easy to make. You take a piece of coax, you cut it to a quarter wavelength, you short the conductor to the shield, and you've got a pretty good, you've got a low impedance trap at a certain frequency, which is easy to make. However, if the situation is reversed, and this is behaving like an antenna, you also have actually resonant amplification, which is not what you want. So these are the possibilities. And my second segue is going to be a quick look at the FCC regulations. Most people are familiar with Title 47, Part 96, excuse me. But if you look at Part 15, that controls radio frequency devices. This is a really busy view graph, and you can look at it at length when these are posted. But what I want you to pay attention to are 2 points. The first is that the upper table shows the permissible conducted limit for frequency emission between 0.15 and 30 megahertz. And it uses an odd unit, well, it's not an odd unit to radio engineers, decibel microvolts, which is not a dimensionless unit. It's actually a reference to 1 microvolt. And what this means is that if on the average you have 316 microvolts on your 120 volt AC line, you are within limits. So the problem comes in usually if you're within limits, but you have a wiring harness which is improperly grounded or long or so forth and so on. The second table shows the test requirements for radiated emissions. And to me, the rather curious thing about it is there is no requirement to test equipment for radio emissions below 30 megahertz. Now, I talked again to my expert friend, and he said that Rigaud is actually starting to test for emission, but it's tricky because emission is very contingent upon the particular wiring you use, how things are grounded, what the wiring harness is, and so forth and so on. But there is actually no requirement for manufacturers to test to see if an ECM radiates any field below 30 megahertz. Okay. Now at this point I've made a lot of new friends. Lennox Field Engineering had paid 2 visits. I had a long and still have a long correspondence with an RFI engineer with Rigaud Bellois, which makes the fan in my furnace. And this is just an obvious note to this crowd, but maybe less obvious to people that read this on the internet. Don't become a silent key by fooling around with your air conditioning without powering it down. My air conditioning has a manual lockout. You pull out the breaker, you invert it, and put it back in. And if you turn off your furnace, you will disable the air conditioner, which is outside, but you will not turn the power off to it. And I tell you, in all seriousness, I had a friend decades ago who accidentally electrocuted himself fatally, and I'm not going to go into details, but it's made me sensitive to these issues. And here kind of is a recapitulation of what I did. I checked my HVAC warranty, which was 3 years into a 10-year warranty, and I worked through the dealer. I did not actually try to differentiate between conducted EMI and radiated EMI, because when I started, I didn't know the difference, but I recommend it to others. When the dealer came out, he did a number of things which would be difficult for you and me to do, because he could enter codes into the system. He turned the furnace blower on without any heating or cooling, without any AC, and I took a screenshot of the interference that was purely due to the furnace blower. Also, the induction fan was blowing at the same time, but that was not the problem. Then he turned the AC compressor on, but kept the condenser fan off. I thought the condenser fan with this big propeller was the problem, but actually it turned out that the AC compressor, the motor driving it, was the source of all the RFI, and not the motor driving the condenser. So, what do we do about it? Well, I kind of split on that. I was put in touch, as I said, with an engineer from Regal Belvoir, which makes the furnace blower, and he said, "Can you give me a serial number?" And I called up ACE, and they said, "Here's the Lennox part number." A part number is not a serial number, nor does it tell you exactly who the manufacturer is. Regal has a number of different brands. But I did identify it, and what ultimately happened was that Regal Belvoir provided a custom RFI filter, which I'll show you, which ACE installed on the furnace blower, and that eliminated the conducted RFI. The Lennox field service engineer found there was a problem with the LG compressor motor, but it was not the fault of the motor. LG was less cooperative than Regal Belvoir. They said they have a large inductive reactance filter, and that's the end of the story. Nonetheless, we are still getting interference. There's also a three-phase drive to the motor windings, and in that case, you have to be careful that the current is properly handled, or you can also get radiated EMI. So Lennox diagnosed and fixed the LG problem due to radiated EMI, and I'll explain how in a minute. Here's my AC unit with the panel removed. On top is the fan, which I was sure was the problem. It wasn't, although both the fan and the motor and the compressor are potential sources of RFI. And here's where I took an endoscope and looked into the furnace and managed to read the faceplate off of the furnace blower. The endoscope has a little mirror on the end and actually reverses the writing. And I went back to Regal Belvoir and I said, "It's a Gentech?" And he said, "Oh yeah, that's one of ours." And I said, "Here's the serial number, G14V222. He says, "Oh yeah, that's one of ours." He said, "That's an ECM3. And he said, "You're in luck, because I had made up 100 custom filters for the ECM3. And I said, somewhat naively, "That's great, but why wasn't it installed in the first place?" And the answer I got from Lennox and Regal was, "Be real. We put in maybe 1,000 units a week, and maybe one person in 1,000 actually has equipment sensitive enough to have problems. So we address the problems after the fact. But in some cases, they are absolutely spring-loaded for this." And that's why it's not sufficient to say, "Yeah, I've got a Lennox furnace with a Lennox blower." If you can, you really want to determine the manufacturer and the serial number and make friends with the people that can help you by being polite, which I usually am, actually. So here's how the furnace blower problem was solved. After I confirmed it, they provided me with a custom RFI filter. I'm just going to go over this very, very quickly. It's a rather conventional design. There's a couple of caps from L1 to ground and L2 to ground, both are hot leads to the furnace compressor motor. And there's 3 binocular clamp-on ferrite chokes. Again, this will be online if anyone cares to study it. Here's a picture of it up on the left with the shrink wrap on the right with the shrink wrap off. and on the bottom, which shows how nicely it plugs into the plug on the ECM3 motor. And that's actually kind of a terrible picture I took just for fun after the dealer installed it for me. Because one thing I did not want to do was void the warranty, 10-year warranty, by trying to fix my own air conditioner or my own furnace. That would have been really bad. So putting that filter on prevented the problem associated, terminated the problem associated with the furnace blower fan. And what does it do? It's right at the point where the AC line is connected to the fan. You have two caps shorting the RF to ground and a series of binocular chokes. Those are clamp-on ferrite chokes. The AC unit was more problematic, required a couple of visits from Lennox. First of all, LG denied any responsibility, and they're probably right. As the arrow shows, they have a large inductive reactance filter, and they say as far as EMI compliance goes, we're fully compliant. And I believe most manufacturers are. They do not like to be out of compliance. But radiated RFI couldn't be ruled out. And here is what Lennox found out, and I never would have figured this out myself. They found there was an 8-wire harness, which you can kind of see roughly in the left-hand picture, between the control unit to the thermostat in the house. But only 4 wires were being used, and the other 4 wires were unused and ungrounded. Sound like bad practice to anybody? And I said, why are there 8 wires when you only need 4? And the Lennox engineer said, oh, we always have extra wires in case you have to add extra devices. But he said, I admit, these should have been cut off and grounded. They never should have been left free. So if you want a nice example of inductive radiated EMF, this is it. Because these wires, which were attached to nothing at either end, were a perfect antenna nonetheless by induction and caused massive RFI on my system.
So they just pulled them out?
I'll show you what they did. In the left-hand picture A, they bared the ends of all 4 unused wires. They tied them together with a cap, they grounded them, and then for good measure, though it's a little bit hard to see, he put ferrite core chokes on each wire. I said, where'd you get the chokes? He said, oh, I got them from Amazon Prime. Where do you get yours? And that fixed my RFI problem. So problem solved. Now, in a way, this may be kind of disappointing because it's not DIY, it's me pleading. Yeah. I want to finish up with a few tropes from the internet. And this will take about 5 minutes, and then I'm done. Take more questions. The most common trope on the internet is, since I'm getting interference, the furnace or air conditioner is not FC compliant. It's usually not true. Manufacturers try hard to make their motors compliant with the regulations as written. A small level of conducted AC EMI is permitted, about 360 microvolts, based on my solution of that equation. Manufacturers are not required to test for radiated EMI below 30 megahertz, which I think is a problem, but it's also understandable because there are so many different ways you can wire up a motor. You'd have to test them all. And radiated EMI can occur because of improper grounding, inadvertent ground roofs, or improper wiring installation, which was partially the cause in my case. This is an example that was sent to me again by this extremely good engineer, Rigo Bellois. He said he was confronted with this problem and tried an EMI filter, which are heavily advertised, and it didn't work at all because it shunted the RF from L1 to L2 to ground, but the return conduction was through the metal case and was being radiated. Instead, he determined that he had to shunt the RF to ground right at the adapter plate. If you look just over the propeller, you'll see the adapter plate labeled just over the motor. And at that point, the filter had to be applied. If you apply the filter at the output from the line, it's not going to work because you already have emitted RFI at that point. And he said that was very instructive to him. So that's just an example of how you can have an inverted loop through a metal case from a ground connector. Which brings me to my second point. Another trope is installing an EMI line filter, of which there are many, will eliminate all your problems. That really depends on the cause of your problems. An EMI line filter may not have any effect on radiated RFI, but it can definitely help if you have conducted common mode RFI from power lines or your neighbor's plasma TV set. I have a CMC choke on my system between the antenna and the lightning arrestor, and that seems to help. I also have a trip light surge protector, which has a cascade of filters which are supposed to reduce RFI. And I played a little bit with leaving them in and leaving them out, but since it seems to work with things in, I just leave well enough alone. And then, of course, there's no FCC requirement for the radiated EMI below 30 megahertz, and I've already gone over of radiated EMI. The third trope is shielding the ECM control cables in your furnace will eliminate RFI. This is particularly interesting because it may work without being the best solution. There's an article that's posted from QST, I think, about RFI mitigation on a Rheem high efficiency furnace, where somebody first put improvised aluminum foil shielding on and then replaced that with full shielding, and it worked. But the question in my mind is, that person might have been better off with a custom filter right at the point where the cable comes in. Or he might also have checked to see if he had the problem I had, where there are ungrounded cables in a wiring harness. So that may work, but it may not necessarily be the best solution. I certainly don't have anything against anybody trying it. I asked the Lennox engineer what he would have tried if grounding and choking the loose wires hadn't worked. And he said, well, in that case, I have a full set of shielded cables, and I would have replaced the entire wiring harness. I mean, he's an expert, but, you know, there's still an element of guesswork here. And my favorite, because I used it myself sometimes, is if the RFI isn't fixed, I'll file an FCC complaint, the nuclear option. Well, you can. It's legal, but there are a whole lot of issues here. The first is the speed of government. The second is that the RFI may most likely be due to local installation issues rather than component malfeasance. The third is if you go to the ARL website, they have an article, which there's a link to, and they point out that the FCC now simply acknowledges a lot of complaints and is told the complaint will be used for statistical analysis. You know, I built mathematical models all of my life, and this kind of warms my heart, but it doesn't solve anybody's problem. If you do file a complaint, you can file an informal complaint for free. If you feel there was no solution, satisfactory solution, you can file a formal complaint for $225. And the final thing is the FCC may just give up. And my last slide is kind of an entertaining example of this. This is from an editorial called The Noise in QST, November 2016. There was a widespread RFI problem in Evanston, Illinois. And I mean by widespread, I mean garage door fob key fobs were no longer opening garage doors. This is serious, right? When you have a whole bunch of people can't get in their garage door. The FCC took it seriously and they said, hey, that sounds like a key fob problem. And they referred the complainants to the Automobile Manufacturers Association, which seems a little bit off point, but I guess they were thinking, well, there is a Society of Automotive Engineers. They probably know more about key fob problems than I do. Eventually, the authorities went to the ARL, and the ARL helped and localized the problem. And they discovered there was, and I'm quoting exactly because this is all the information I have, quote, an errant neon light power supply was causing widespread RFI, which crippled and disabled local key fob garage door openers and automobile key fobs. And isn't that amazing?
You know if this is over a large area?
It says it was. You can look up the article. Yeah. And finally, for acknowledgements, I think ACE did a terrific job because my system was under warranty. They came out several times, didn't charge me anything. They got Lennox Field Engineering to come out or put me in touch, and Lennox Field Engineering agreed to come out. I shouldn't say it was direction. Lennox put me in touch with an RFI specialist at Regal Benoit, and he was terrific also. He actually provided me with a custom filter, and I've told you that story. And with that, I think I am done.